Equations and units practice number 7. Extract. Get the data out of the question. Choose a formula. Best from memory, right? But if you're allowed an equation sheet, use the equation sheet. Check out and convert the units. Convert them. Substitute in, do a bit of football stuff, swap the numbers into the formula. Solve it, round it, put in the correct units. Okay, so a diamond ring has a mass of 0.035 kilograms and a volume, so we've got mass of 0.0035 kilograms and a volume of 0.025 centimeter cubed. Calculate the density. Right, now it's looking a bit funny here, grams per centimetre cubed. Right, so we've got a units issue. So where it's got kilograms, we need it in grams. So 0.0035 kilograms, changed by 1,000, will be then 3.5 grams. All right, now I did that the wrong way around really. I should have done my formula first, shouldn't I? So I'll put it down now. Density equals mass divided by volume. I was just so excited about the kilograms into grams. Couldn't be any better, could it? Grams per centimetre cubed. This is in grams, which is unusual. Centimetre cubed. But what I've done is I've looked at the question here because that's what it tells me to do. Density equals mass. So the mass is now 3.5. Divided by the volume is 0.025. So my answer, 3.5 divided by that, is 140 grams per centimetre cubed. A 1.8 kilogram bucket of water, so mass equals 1.8 kilograms. The specific latent heat of vaporization is 2260 kilojoules per kilogram. Okay, this all sounds very exciting. Calculate how much thermal energy was needed to change the water state. Give your answer in standard form. Right, so change in thermal energy. Okay, I'm very lazy here. You're not allowed to do this. Okay, you've got to write it out full. Equals mass times specific latent heat. So my mass is 1.8 kilograms. Specific latent heat, they've done it in kilojoules per kilogram. I want joules per kilogram because that's what it's measured in. Is 2260 kJ per kilogram equals 2260, add on 3 noughts, joules per kilogram. So multiplied by 226000. So the change in thermal energy is 4068000 joules. But they want the answer in standard form, right? So you always have the 4, which is kind of the first number, and then you have a decimal point. And then you've got to do is you've got to work out how many it's going to move by. So at the moment, let's change the colour. At the moment, the decimal point is here. So what I'm going to do is I'm going to move my decimal point 1, 2, 3, 4, 5, 6. So I'm going to go 4.068 times 10 to the 6. Joules. That's a J. Okay, so an astronaut landed on Mars. Okay, the astronaut has a weight of 284 newtons. Okay, the gravitational field strength on Mars is 4 newtons per kilogram. Calculate the mass of the astronaut. So we need to find our equation using weight, gravitational field strength, and mass. Right, and that is weight equals mass times gravitational field strength. That's in newtons, that's in kilograms, and that is in newtons per kilogram. So weight is 284. We don't know the mass. Gravitational field strength is 4. So it's times on this side. We divide on the other. So it's 284 divided by 4 equals the mass. And the mass will then be 284 divided by 4, which is 71 kilograms. A husky, right, back to those cuddly huskies again, right, pulls a sled, distance 1.5 kilometers, I can see the bottom already, with a force of 25 kilonewtons. Calculate the work done in kilojoules. Okay, there's lots of kilos going on here, so we've just got to follow the pattern anyway. Work done equals force times distance. Okay, now we've got to convert. So 1.5 kilometers equals 1,500 meters. Doesn't matter, you just got to follow the pattern every single time. The force, 25 kilonewtons, equals 25,000 newtons. So therefore, work done is 25,000 newtons multiplied by the distance of 1,500. That comes out at 375,000,000. I like putting little commas in there for every thousand. Calculate in kilojoules. So that is joules. So what we do then is we divide by 1,000, so it's kind of cutting it there, is 37500 kJ. A piece of bubblegum is stretched 75 centimeters. So that must be a distance because it's in centimeters. With a force of 0.9 newtons. Calculate the spring constant. Right, so we look up our formula. Force equals spring constant times extension. Okay, distance, we know it's got to be in meters, so therefore it will be 75 centimeters equals 0.75 meters. So we go to our substitute in, force is 0.9 equals a spring constant, we don't know, times by extension 0.75. Because it is times on this side, it becomes divide on the other, so 0.9 divided by 0.75 equals a spring constant of 1.2. And then the units are newtons per meter. Again, they're just getting slightly harder, but follow the path, follow the 1 to 7 steps. If you can do that, you're sorted.